Hello everyone. In this video, I will discuss how to write up the conclusion. So your conclusion should be written in paragraphs, sort of coherent paragraphs, and your conclusion should be sort of a narrow summary of these are my results, okay? These are the results of the experiment. You will eventually go into discussing sort of more big picture things in the evaluation. In the conclusion, you should straightforwardly describe the relationship between your investigated variables with reference to your research question. So give the exact equation of the best fit line of that raw data table and graph. So the best fit line for that graph with appropriate units, and then describe it qualitatively. So state, say what exactly that relationship is in a qualitative way. Then state the quantitative result of your experiment. So the value of G obtained was, for example, 10.1 plus or minus 0.7 meters per second squared would be perfect. Okay, so you give the value and the calculated uncertainty. And notice that is the calculated uncertainty from the gradient. You can also then give or give that uncertainty using the percentage uncertainty. You're then going to justify your claim while referencing the tables and the figures in your previous section. So reference the tables and the graphs that you've already made. You want to explain or interpret the results in relation to the predicted theory or values, particularly if you did not get exactly what was expected. You want to do your best to explain why you got the results you got in a qualitative way, and you're going to use the percentage error and uncertainty to inform your interpretation. This includes at least a paragraph in which you discuss the scientific explanations or scientific implications of your experiment. So you're using scientific theory to explain the results. Then, and here's the key part, you're going to discuss the relative uncertainty and error. So was the percentage error within the percentage uncertainty or not? If both of them are small, then you're both accurate and precise. But if the percentage error lies outside the percentage uncertainty, then you would say that the systematic error is dominating the random error. If they are around the same size, you would say that they are about of equal importance, okay? And if the percentage uncertainty is much bigger than the percentage error, then likely you had very little systematic error and random error was dominant. And it probably means that you overestimated your uncertainties somewhere along the way. Okay? The end of this discussion, with accurate use of the words systematic and random error, accuracy and precision, should lead conceptually to the evaluation. So was your data accurate, precise, both or neither? Was it dominated by random or systematic error? And if systematic, in which direction? No matter what your answers to these questions are, the end result should be an evaluation that is going to discuss sources of error or methodological issues that reflect your particular results. So the sources of error or methodological issues I want to see in the evaluation should not be the same for every student's results. It should reflect your particular percentage error and percentage uncertainty. For example, if you have a systematic error that suggests your value is too big, then the sources of error you should discuss, at least most of them, okay, not all of them necessarily, but some of them, should be sources of error that would produce that kind of error, okay? You are looking in your evaluation to discuss sources of error that would, that are in fact responsible for your results. Not only do you want to discuss possible sources of error, you want to get it right. You want to get why your values were off to the extent that they were off.